Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering projection of planes and lines. We are at lecture number 40. In the last class, we tried to look at projection of planes and had an idea about auxiliary planes through an example. For example, we have taken a pentagon in the last class, which is of 30 mm sides, with one of the side is 45 degrees inclined to xy axis, and front view is a line 45 degrees inclined to xy. Then we try to figure it out what might be the true shape. So, for that problem, what we have done, first drawn a pentagon, regular pentagon, one of the side is making 30 degrees angle with this xy axis. After that, we projected these points A, E, D, C and B all the way into that front view, where the front view is making an angle of 45 degrees. Because one of the sides is 45 degrees inclined to this xy axis. After that, we draw a true shape from this view, because auxiliary plane concept is useful when you have front views and top views are given, but these front views and top views may not be the true length information. Using that, what we have drawn, we have used a auxiliary plane x1, y1, then projected these points A prime, B prime, E prime, C prime, D prime points in such a way that the distance between these xy plane to these points represented into A1, B1, C1 and D1 and E1. Joining these things, we got the true shape. In today's class, we will learn in detail about our auxiliary plane concepts, whether these auxiliary planes has to be constructed with respect to horizontal plane or vertical plane or on both. Let us begin our session. So, about auxiliary planes, when different projectional views, especially orthographic projections, this could not show true lengths, then we employ this auxiliary plane method. The additional planes of projection other than three principal planes of projections, that is our front view, top view and right side or left side views, which will show true lengths, are called these auxiliary planes. So, when we are picking a plane, not our vertical plane, horizontal plane, not profile plane, but a plane which is either inclined to horizontal plane or vertical plane or both, when we are projecting that object onto that plane, we may get true shape. Usually, these are constructed parallel to the edge, which is to be shown in true length and perpendicular to any of the three principal projection planes. So, our principal projection planes are always be vertical plane, horizontal plane and side or profile plane, and these auxiliary planes may make an inclination angle with them. And the true shape or true length we would like to find. So, the way how this true length is aligned, in that direction we pick this auxiliary plane, so that this plane may make orthogonal or 90 degrees with the other planes. So, there are mainly two planes. One is auxiliary vertical plane, other one is auxiliary inclined plane. Let us look at the first one. If the auxiliary plane is selected perpendicular to horizontal plane and inclined to vertical plane, that means let us draw a picture. This might be our vertical plane and this is the horizontal plane. It is supposed to be perpendicular to horizontal plane, but inclined to vertical plane. That means perpendicular, it can be a plane in that direction. It can be such kind of plane, or it may be making inclined with vertical plane. So, the general inclination angle, if we are going to draw that, this auxiliary plane. So, inclined one, but still perpendicular. So, this is the plane what we are talking about. This is vertical plane and this is a horizontal plane, and we have an auxiliary plane which is making 90 degrees with horizontal plane, but it makes a inclination angle with respect to vertical plane, because if we are connecting, this entire plane is going to intersect there and is making an angle. If we have such kind of planes, the views of the object projected on the auxiliary plane is called auxiliary front view. In the same, our auxiliary plane is in this direction. For example, if we might be having some square block. Now, if we are projecting onto that plane, what we are going to see is the complete height of that object on the vertical plane, whatever that true height, that we will see it on this auxiliary vertical plane. So, that auxiliary front view and the auxiliary plane is called auxiliary vertical plane and denoted as AVP. So, we are going to take projections onto that inclined plane making inclination angle with vertical plane. If the auxiliary plane is perpendicular to vertical plane and inclined to horizontal plane, this is the vertical plane, horizontal plane, let us call vertical, this is horizontal plane. Now, it is perpendicular to vertical plane, but inclined to horizontal plane. That means, if I am drawing a plane in that way, let us use some color. This is the plane what we are talking about. If we are extending that, it is going to make an angle with the horizontal plane. So, this plane AIP, let us call this inclined plane auxiliary inclined plane, making an angle with the horizontal plane, but when we are measuring, this always be 90 degrees with the vertical plane. And that kind of plane is called auxiliary top view, and the auxiliary plane is called auxiliary inclined plane. So, whatever the projections we are going to get on that plane, auxiliary top view it becomes, and the plane is called auxiliary inclined plane. So, a auxiliary vertical plane, the projections what we are going to achieve are called auxiliary front views, and for a auxiliary inclined plane the projections what we are going to get is auxiliary top views. So, if we are generalizing this entire planes concept, mainly we have principal planes. One is our vertical plane, horizontal plane, these are called principal planes, orthogonal to each other. The additional one is our profile plane, which usually we consider orthogonal to both the planes, that is this one, it is perpendicular to both horizontal plane and vertical plane. The other category is called auxiliary vertical plane. It makes 90 degrees angle with the horizontal plane, makes an angle with the vertical plane. So, the projection, any object whatever the projection we would like to really consider, that has to be in between vertical plane, horizontal plane and auxiliary plane or auxiliary vertical plane. For that only we can take these projections. Once we take these projections, we flip this auxiliary vertical plane in line with this inclination angle. So, if we are taking any flip rotation about this thing, we can rotate about this, so that the projected view we will take it. Similarly, if it is auxiliary inclined plane and auxiliary top views, for that what we have is this auxiliary inclined plane makes an angle with the horizontal plane. This is always be perpendicular to vertical plane. So, any object which is in between vertical plane, horizontal plane and auxiliary plane, the projections if we are going to see it, that will be taken on this inclined plane. About this axis we construct the projections. In the last class we have seen this pentagon. In that pentagon, auxiliary plane we have made in such a way that that was making a particular angle. So, in next couple of classes we will learn more about these auxiliary planes for the lines, planes and also solids. First of all, we will learn how to construct projection onto auxiliary vertical plane. Let us begin with a point P. Here we have this vertical plane, horizontal plane, and our auxiliary plane is this. This is an auxiliary vertical plane because it is making 90 degrees angle with respect to this horizontal plane, but making an inclination angle with the vertical plane. So, whatever the vertical plane we have, with respect to that there is an angle, and because of that we call this plane as vertical plane, auxiliary vertical plane, and there is a point P. If we are projecting the coordinates for this P point onto our vertical plane and horizontal plane, the coordinates will be this one, which is P here, and if I am projecting, this will be P prime. Now, the true length we may be seeing in the vertical plane if we are projecting P onto this VP. This is height above horizontal plane. the true length what we might be going to see is this one m. So, if we are projecting on the vertical plane also m we will see. When we are projecting this P point all the way onto this auxiliary vertical plane, again the height what we are going to see is m. This is the height above the horizontal plane, because it is a vertical plane and auxiliary one, we use a notation which is P prime 1, the first auxiliary plane. And the projection of this point P all the way down is P, and that projection all the way there we call O1. So, the coordinates of this P point which is projected onto auxiliary plane are giving us O1 P1 prime. Usually this point P, when it is set up in that way, the auxiliary plane makes an angle phi with respect to the vertical plane. The notation what we use for this auxiliary vertical plane is it makes an angle phi with respect to vertical plane. P prime is always be projection on VP and P is the projection on HP. P1 prime is projection on AVP, auxiliary vertical plane. And true lengths where we will find especially height above horizontal plane for such kind of points. On VP we will see that is M, and on auxiliary front view we will see this is the plane. If we are rotating it, then that becomes the front view, rotate it in that direction, then we will see that as the frontal view of this auxiliary plane. And we rotate that about this axis x1 y1. So, fix this x1 point and rotate it so that we will be in a position to see that. The other way is look at it in 3 dimensions. The front view always be that, the top view always be there. There is a line, if we are drawing, redrawing the views, this is the front view, this is the top view. This line x1 is making an inclination angle with the horizontal plane. So, somewhere here we make such kind of x1 y1 plane. This is anyway making an angle with respect to this horizontal thing. So, this is the angle what we are saying as phi angle. We draw this auxiliary plane x1 y1, project these points informations from here all the way. If we are projecting this point P prime, it projects there and that goes all the way there. Similarly, this point P comes there, all the way goes to that point. So, if we are projecting some point, this one we have to project to that point and we are rotating it in that direction, it comes all the way there, and this P point projected to there, that comes to that point onto the auxiliary plane, and from there it goes parallel to that line. So, parallel to that line, if we are in a position to construct around that, we will be in a position to construct the views. So, by rotating this HP 90 degrees, we bring it to the plane on VP. So, let us go back. So, we have to rotate it by 90 degrees to this HP, so that we will be getting this plane, this one. By flipping it in that direction. Once this HP lies in plane with VP, the AVP is rotate about x1 y1 line, so that it becomes in plane with that of both horizontal plane and vertical plane. So that pictorially here we are showing x1 y1, we are going to rotate it so that it makes an angle phi angle with that, and that entire thing is AVP plane, and this view is auxiliary front view. Steps to be followed, let us pick it through an example. The same point P where we have both the front view and top view. First step is draw XY line and mark point P and P prime. So, first what we will do, XY plane we will write, draw, then mark point P and P prime. So, P point in the top view, P prime point in the front view we will draw. Then second point, auxiliary vertical plane is inclined at phi angle to VP. So, already we know XY axis, P primes are noted down, give some distance, draw a line x1 y1, x1 y1, but it is supposed to make an angle phi with respect to our vertical plane. So, that projection what we will see it with respect to xy, and this plane can be here, it can be there also. So, at any arbitrary distance we should be in a position to construct this plane. Then point P is at a height m above. That means that height above we will see it in the vertical plane. So, OP prime is m. The auxiliary front view P1 prime will also be at a height m above the x1 y1 line, because the point P we are projecting it onto auxiliary vertical plane. So, about x1 axis, x1 y1 axis, it will be above on the other side. So, this is the x1 y1 axis above that point, because it is a vertical plane projection also front view. So, it will be P1 prime, and this distance m we have to maintain, because there is a true length what we will see in the frontal view. This frontal view can be our vertical plane thing or AVP's frontal view also. After marking P1 prime, if we measure O1, this is the intersecting point P1 prime, if we are dropping there by a line, O1 P1 prime is equal to OP prime. That is the way we mark it. Thank you very much.